All right, guys, we're going to do two sections today. It's 3-3 and 3-4. We're going to talk about change of base formula. We're going to talk about expanding and condensing. And then we're going to talk about solving. So the first thing I want you to do is look at your calculators. If you guys don't have a calculator, okay, you have to have one and have to know how to use it before Tuesday. You cannot come in with your friend's calculator and say, hey, can you just show me this real quick? That's not going to work. So we need to know how to use our calculator, okay? We're going to talk about the change of base formula. Now, in your calculators, and some of yours do change of base, some of them don't. I'm not going to teach you how to use your specific calculator. But if you see the button, does everybody see the button that says log? All right, if you hit log, the word log comes up. The little number that's down in the corner, do you see how this is log base 4? In your calculator, it is already programmed to be log base 10. So anything that you hit, like if you hit log 25, it's not going to be the same as if it was log base 4 of 25. So your calculator is based in base 10. So we're going to do something called the change of base. You're going to have to use this when you're solving. If you look on your calculator, do you see the ln button? Okay. And you know, okay. So ln, that's just natural log. Okay. So logarithms and natural log, same thing. But ln and e are inverses of each other. We have to remember that. So if you see ln, you think e. But if it says ln, use the ln button. If it says log, use the log button. So when you have a problem like this and they want you to use the change of base formula, you have to take the log in your calculator. You would hit log of the physically bigger number. So I'm going to say large number and divide it by the log of the tiny number. I mean physically, not in value. But which is the large number and which is the tiny number? Okay, so in your calculator, you guys would hit log 25 divided by log 4, and then hit enter. What do you get? At 2.321. Okay, that's using the change of base formula. So how would you do it in your calculator for B? Log 12 over log 2. So in your calculators, hit log 12, close your parenthesis, and then divided by log 2. What'd you guys get? 3.5849, so 585, something like that. Okay, perfect. Now, if you were going to do the same thing, and it says use the change of base using natural logarithms. Well, which button do we use if it says natural logarithms? ln. You did the exact same thing, guys. Do ln of 25 divided by the ln of 4, and tell me what you get. What did we get? 2.321. Is that what we got up here? Okay, same thing. Do ln of 12 over the ln of 2. What do you get? 3.585? Okay, so look, natural logs are still logarithms. You just use natural log when it says ln. And we know that ln and e are opposite of each other, inverses of each other. Okay, here is the very most important thing that you can remember from our 3.3 lesson today. And it's actually not hard. It's a little harder when you look at it with letters, but it's not hard when we put numbers to it. We have something called the product property, the quotient property, and the power property. So what we have to remember is, because we're going to condense and expand. If you condense something, does it make it smaller or bigger? Smaller. And if you expand it, it makes it bigger. Super duper important. Product property. I want you guys to write next to product property. Multiplication goes with addition. Multiplication goes with addition. For your quotient property, division, what do you think goes with? Good. With subtraction. Good. Very good. And then when we talk about the power property, exponents goes with coefficients. I'll explain that to you in a second. But for your product property, if something is being multiplied and they're asking you to expand it, you should think addition. If something is being added and they're asking you to condense it, you should think multiplication. Those two operations go together. Division, subtraction go together. Exponents become coefficients. Coefficients become exponents. So if you start off with your log, do you see how you have log base A here? And this is U times V. Everybody see that? You know it's U times V because they're stuck together. When you are already condensed, we're already smushed together. If we want to pull it apart, each thing gets its own log. Since it's being multiplied, what goes with multiplication? Addition. So do you notice that each of them got their own log base A, and we pulled the U and a V apart, and we added them together? Does everybody see that? Yes. All right, so if we started off pulled apart, you guys would see, ooh, that's addition. So what goes with addition? Multiplication. When you're condensing, you're going to rewrite something with just one log. When you're expanding, everything gets its own log. So here, what is U and V doing? Dividing. So do you see how, it's log base A, they're dividing. So when we pull it apart, your division becomes subtraction. Here, my exponent, when I'm pulling it apart, my exponent became my coefficient. If it was already a coefficient, it would become my exponent. Just goes back and forth. Okay? Same thing for natural log. So let's just look at some examples. This is easy to do if we just look at some examples. Okay, so if we're going to attack this problem, right? On your test or quiz, it's not going to say expand this or whoa. So if you look at letter A, is this already expanded or is this already condensed? It's already condensed. You see how you have one log base 4 and everything is smushed together, right? So before you even try to do anything, what is 5, x cubed, and y? Oh, it's all happening to it. They're being multiplied. So what do you think of when you think, okay, they're being multiplied. When I pull it apart, what are they going to be? What's going to happen? They're going to add. Good. What does that exponent of 3 become?
A coefficient.
3 becomes a coefficient. So guys, just like it's that simple. Everything gets its own log. So I'm going to write log base 4 of what? Of 5. Good. Since they're being multiplied, what sign do I put in between when I'm pulling them apart? Plus. So I have log base 4 of x cubed plus log base 4 of y. Does everybody agree? Okay, do I have everything in one single line with no exponents?
No.
No, right? Do I have one more thing that I can do to expand this even more? Where does this 3 go? It's going to go right here in front of that log. Now, could some of you are going to say, can I just do that all in one step? Yes. But this is the first time, or some of you it's the second time because you saw this last year, of you seeing this. So I think it's a good idea to take your time and do everything one piece at a time. The biggest thing I can say to you guys is if you see multiplication, what should you think in your mind? Addition. If you see division, what should you think in your mind? Subtraction. If you see exponents, what should you think? Coefficients. Good. All right, so let's look at B. Just talk through B for a second. Talk through B. What's the first thing you see? Division. Good. You see anything else? Do you guys see an exponent, kind of? What'd you just say, Camila? Square root. Is there another way I can write the square root of something? With an exponent?
If 3 in parentheses 2x minus 5 squared?
Not squared. I like what you're thinking. Half. Very good. You guys can rewrite this, look, as the natural log of 3x minus 5 to the what power? To the 1/2 over 7. Guys, if it was the cube root, what would my exponent become? 1 over 3. If it was the 8th root, what would my exponent become? 1 over 8. Good. So now you guys told me that you see division, right? Well, when we pull apart, everything gets its own log or natural log. So and the way you see it is the way you write it. So numerator over denominator. So I'm going to say the natural log of 3x minus 5 to the 1/2 minus the natural log of 7. Agreed? Yeah. Is there one more thing I can do to pull this apart even more? This 1/2, perfect, is going to come out in front. So I have 1/2 natural log of 3x minus 5 minus the natural log of 7. Now, somebody asked me a couple years ago, they're like, if it's natural log, why isn't the abbreviation NL instead of LN?
That's what I was thinking.
It's because it's Latin. So any of you that are Hispanic, I know my husband is, right? Don't you switch the adjectives? Like pretty shoes is zapatos bonito. Yeah, right?
Like White House is like.
Right, White House is house white. So same thing. Natural log is log natural. Does that make sense, guys?
Yeah.
Given your problem is not going to give you this and say condense it. It's going to give you this and say condense or expand. You need to know if it's already expanded, how to smush it together, and if it's already smushed together, how to pull it apart. When I give you these problems, A, B, and C, are they smushed together or are they pulled apart? They're pulled apart. First thing you got to look at is, are the log bases the same? Both log base?
No.
They're both log base 10, aren't they?
Yes.
Okay. Right? What does this plus sign mean I'm going to do with them? I'm going to multiply. If I have if I have coefficients, where are they going to go? Exponents, good. Okay, so just don't even worry about doing everything at one time. Just kind of look at it and assess the situation. So I'm going to say A, and I don't do everything in one felt swoop. I like to do things in steps. So the first thing I'm going to do is I'm going to move my coefficients to exponents. So I'm going to rewrite this as log base 10 of x to the 1/2 plus log base 10 x plus 1 to the 3rd power. I just like to do that. It makes it easier for me once I have my exponents out of the way. Yes, sir.
Do we then have to put in the square root or we don't have to?
Yes, in a second. Hang on. So now I'm going to say, all right, they both have log base 10. So you write log base 10 out front one time. And now we say, okay, I have x to the 1/2 times, do you guys agree? X to the 1/2 times x plus 1 cubed. All right. All right, so the last thing we have to do when we pull this together is we have to say log base 10, and instead of x to the 1/2, it's the same thing as a square root, and then x plus 1 quantity cubed. You can leave it just like that. You do not have to multiply that all out. All right, let's look at the next one. Now let's think for a second. What's going on here? Subtraction, which means division. Good, I like that. Good job. And then I see this too. What does that mean? Okay, it's going to become an exponent. So I'm going to rewrite this as the natural log of x plus 2 squared minus the natural log of x. Can I smush together a little more? Yes, I could rewrite this with the natural log just one time out in front. And then I have x plus 2 squared over what? Over x, just like that. And just leave it. That's condensed. That's smushed together. You do not have to multiply the top out. All right, let's look at C. C's got a lot going on, doesn't it?
Yeah.
C's got a lot going on. What's the first thing you see? Okay, I see this addition, which tells me I have to do what? Multiply. All right, what's another thing you see way out in front? Do you see the 1/3? It's the whole thing, right? Do you guys see how that 1/3 is with the whole thing? So this 1/3 is going to come way back over here. Y'all see that? So I'm going to rewrite this just so we can, I like to go step at a time. Log base 2 of x plus log base 2 of x minus 4. And all of that is raised to the 1/3 power, which at the end, the 1/3 power is the same as what?
The square root of 3.
Not the square root. What do we call that? Cube root. Good. Okay, so now I'm going to rewrite this whole thing with what log?
1.
Just 1 log base 2. So I have x, what? No.
X
Times x minus 4 raised to the 1/3 power. Can I simplify that? Can I smush that together just a little bit more?
Yeah.
What would this be? Log base 2 x times x minus 4. That's going to be underneath what? Not the square root, guys. It's the cube root. There's a 3 out in front there. Good. Very good. All right, that was 3-3. Now we're going to 3-4. We're solving. We love to solve because at the end we can check our answers. They may not be beautiful, but we can check them, and I'm going to show you how. All right, here's a whole bunch of examples. These can be very helpful for you guys if you are ever stuck and you're like, wait, I forget what to do. You can always look back here. When we have our one-to-one property, we like the one-to-one properties because we say, oh, okay, if I get the bases or the logs the same on one side, same on the other, I can cross them off, right? So like in letter A, 2 to the x equals 32. Well, you could rewrite 32 as 2 to the 5th. You guys see that? If you notice here in B and C, do you see how your log base is the same? And then it's 0 on the other side? Only works if it's 0 on the other side. Right? So you can move them over, cross them off, no big deal. Then we get to where we have to solve using inverses. Everyone write this down. This is the crux of this lesson. Exponentials and logs are inverses of each other. So if you're starting off with an exponential, in order to solve the equation, what's the opposite of an exponential? Log. If you start off with a log equation, in order to solve it, what is the inverse of logs? Exponentials. All right, and the other one that's super duper important, e to the x and ln are inverses of each other. If you start off with an e to the something, at some point when you solve, you're going to use the ln button. If you start off with an ln, a natural log, at some point in your solving process, you're going to use what? E to the x. Now, when you guys are solving these problems, the first and second steps are generally the pre-calc. Everything else is algebra that you've done before. All right, so here's our rules of what I just told you. But if I was going to tell you guys, solve this, all right, I'm going to tell you I think is the best way for you to attack all of these problems. The first thing you do is you isolate your function. What am I starting off with in letter A? What am I starting off with? What does it look like? What does it say? It says e to the x equals 72. Is e to the x all by itself?
No. Yes.
Yeah, there's nothing being added, subtracted. Oh, gosh, bad color choice. Sorry about that, guys. Okay, e to the x is all by itself. So I don't have to get anything to the other side by using our inverse operations. I now have to get x by itself. Well, we have to do the inverse. What is the inverse of e?
ln.
So if you take the ln of one side, right, what happens with ln and e? They cancel, so I get e. Well, what you do to one side, guys, you have to do where? To the other. So in your calculators, hit ln 72. 4.7 what? 4.276. Now I need everybody to do this with me, please. Please, please, please. 4.276, right? I got x equals 4.276. Well, how do I know if I'm right? You plug it in. And there's going to be times when you have to plug in to check for extraneous solutions, and these ones you don't. But I'm going to show you how easy this is to do. Now, in your calculator, guys, hit your second ln button so the e comes up, and then put in 4.276, and then hit enter. What'd you guys get? 71.952. Is that really close to 72?
Yeah.
How come it's not exact?
This is not the exact.
Because we had to round, right? We rounded. But you guys, when you plug back in, you should get something really close to what you started with. Now, as we go through this, if you guys don't get the same answers that everybody else does, please stop me so we can go back and check to see where we went wrong. All right, let's look at B. The first thing I'm going to do is I'm going to tell you guys every single time, just like if you were doing absolute value or something like that, isolate the function. Do you see how this is 2 to the x power? What kind of a function is that? 2 to the x. Is it a logarithmic function? Is it an exponential? What is it? It's an exponential function. What's the inverse of exponentials? Logs. Okay, remember that. I need to get that exponential function completely by itself. So what do I do to both sides? I'm going to divide both sides by 3. Anybody have any questions on that? Okay, so I'm left with 2 to the x equals, what's 42 divided by 3? 14, good. So now my 2 to the x is by itself, right? Mm-hmm. Well, what did you guys just tell me a second ago? The opposite of exponentials was?
Log.
Log. So if I want these to cancel out, I would have to make this log. What log base would it have to be? 2, right? One of our properties was if it's log base 2 and then you have a big 2, they cancel out. So if you do log base 2 on one side, what do you do to the other? Log base 2. So this cancels and I get x equals. Well, how do I do this in my calculator? Yes, sir? You put log 14 over log 2. Do you guys see everything that I'm writing out here? This is what I expect to see on your test. Don't do everything in your calculator and give me an answer because I will not give you credit. I need to see these steps. Round, guys, for me to 3 decimal places. 3.807. Somebody do that with me. Do that, please. 3.807. All right, let's look at the next one. Do we have any more on this page or no? Nope, okay. Oh, yeah, we do. Whoops. All right. Guys, this is an equation. This is a normal equation that we've seen 100,000 times. First thing we do is isolate our function, right? I have an e to the 2x. E, what's the opposite of e? ln. E and ln are opposite of each other. So I have to get that e to the 2x by itself. So what do I do? Hold on, what do I do first? Guys, it's just like solving 4x minus 3 equals 2. Nope. I'm going to add 3. So plus 3. So I have 4 e to the 2x equals 5, right? And then what? Divide by 4. Divide by 4. So I have e to the 2x equals 5 over 4. Do you guys agree that my e is now by itself? Okay, what did we say at the beginning? What is the opposite of e? ln. If I take the ln of this side, I have to take the ln of the other side. When I have e and ln, what happens to them? They cancel, so you have 2x equals. Guys, when you do this in your calculator, you need to hit ln and then parenthesis 5 divided by 4. Close your parenthesis. If you don't, it'll take the natural log of 5 and then divide that by 4. So give me at least 3 decimal places for, wait, say it again. 0.223. Okay, and then what do I do to get x? Divide it by 2. So x equals what? 111? Something like that? All right, there you go. And what can you do with 0.111? All you're doing is just solving a simple equation. The only thing that is pre-calc is right here. That one step of knowing that natural logs and e are inverses of each other. But other than that, you guys just solved a simple 2-step equation, right? Okay, good. Good. Can you get the door, please? Thanks. All right, look at this one. A lot going on here, yeah? All right, I'm going to rewrite it with an x because we all know what's up. Hi. Oh, okay. So I have 2 times 3 to the 2x minus 5 minus 4 equals 11.
In the military, can you do that?
As an officer.
Around 4 years?
Yeah, I think so. Okay, so look. It's really hard to get into, though. You have to get, like, letters from your congressman, and, yeah, it's a big deal. All right, do you guys notice here? This is what kind of a function? Is this an exponent? Did you say it's an e?
The e.
I don't see any e's.
The e one.
No, there's no e's in this problem at all.
But what's the e?
It's 3 to the something power. This is an exponential function. What's the opposite of exponential? Logs. All right, so what I have to get this by itself first. So the first thing I do is add 4. Good. So I have 2 times 3 to the 2x minus 5 equals 15. Now what? Perfect. Divide by 2. So we have 3 to the 2x minus 5 equals 15 over 2. Wait as long as possible, guys, to do any division. Because if you round too soon, the more you round, the further and further away your answer gets from the exact answer. So we said here at the beginning, this was an exponential. What is the opposite of exponential? Log. So I'm going to say log base what? 3. Whatever the big number is, that's going to be your little number, so they cancel each other out. So if I have log base 3, on one side, then I have log base, what? 3 on the other. So 2x minus 5 equals, in your calculator, guys, pay attention. It's log of the big, huge number, visually, over the tiny one. So your calculator should say log, and then you do 15 divided by 2, divided by log 3. What do you guys get? Look at you guys. 1.834.
Yeah.
All right, now we go back to 6th grade. Solve this. What do I do? I'm going to add 5. So 2x equals 6.834. And then what? Divide by 2. So x equals 3.417. And then what can I do with that answer to make sure that I'm right? Plug it back in. If you guys notice, in this whole entire problem, the only pre-calc step is right there. Everything else is basic algebra that you guys have learned before. Okay, do I have any more on this page? Yes. Ooh, we got bunches more. Okay. Natural log. Natural log and ln are what of each other? I mean, sorry, natural log and what are of each other? Inverses. Sorry, I couldn't think of the word I'm looking for. Do you guys see how this is the natural log of 3x? Yes? Just because there's a 3 in there, it doesn't change how we do stuff, but you can't divide this by 3. The 3 is not on the outside. The 3 is with your natural log. So I immediately look at this and I go, oh, well, what is the inverse of ln? E, I have, if I take the e of this side, then I do what? Take the e of this side. So this becomes 3x equals e to the second power. That 2 just becomes your exponent. So guys, in your calculator, what is e to the second power?
7.389.
So 3x equals 7.389. And then what do I do? Divide by 3. And x equals 2.463. And what can I do with my answer? Plug it in. Good. All right, let's look at B. I have log base 3 of 5x minus 1 equals log base 3 of x plus 7. What do we notice here? They have the same logs. If they have one log on one side and one on the other, and they are the same, what can I do with them? I can cancel them out. Good. So this just becomes 5x minus 1 equals x plus 7. There you go. So I'm going to subtract x from both sides and add 1. And I get 4x equals 8. What does x equal? X equals 2. Now, very, 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 very important. At this point, you have to go back and check. What you need to go back and check, write this down, circle it, star it. You cannot take the log or ln of a negative number. In your calculators right now, hit log -2. Not -2, hit the little negative button. And what does it tell you? Error. Hit ln -5. Error. You cannot take the log or the natural log of a negative number. So when you get a problem like this, you just have to make sure that your log does not become negative. If I plug 2 in here to the original, what's 5 times 2? 10 minus 1.
9.
Is that negative? No, you're good. What's 2 plus 7? 9. Is that negative?
No.
Then you're good. If you were to plug that number in and either one of those became negative, your answer would be no solution. You guys are going to see that, so let's just be careful here. All right, let's isolate. Isolate here. Is this the next problem? Yeah. Isolate your natural log. I just have natural log of x. Do you see how that 2 is on the outside? So we got to get rid of it. So what am I going to do? I'm going to subtract 5. So I have 2 times the natural log of x equals -1, right? And then do what? Divide by 2. So I have the natural log of x equals negative 1/2. Okay, is my natural log by itself? Yes. What? Look at your calculator. What's the opposite of ln? E. So look, I'm going to put E here as my base, and I'm going to put E here as my base. So E and ln cancel. X equals E to the negative 1/2. Do that in your calculator. What do you get? X equals, so 0.606, 607, something like that. Now, what do I need to do? I need to make sure when I plug this in, well, when I plug in 0.607, is that a negative number? No, then we're good. Good job. 2 more. We're almost done. All right, let's go. Let's isolate our log. Do you see how that 3x is stuck there? Okay, so it has to stay there. So in order to get log base 5 of 3x by itself, what do? Divide by 2. So I have log base 5 of 3x equals 4 divided by 2 is 2. All right. Now I need to get log base 5 to go away. What's the opposite of log? Nope. Exponential. No. E and ln go together. Those two are separate. Those are natural logs. Log and exponential go together. So if I have log base 5, what is my big base going to be on both sides? 5, because they need to cancel out. So I write my big base, and then this becomes my exponent. And what you do to one side, you do to the other. So I have a big 5, and 2 becomes my exponent. Now what happens with log 5? Log 5 cancels. So you have 3x equals, what is 5 squared? 25. Divide by 3. And x equals about what? 8.333. Okay. What do I need to do with that? I need to check it, make sure that it doesn't make my log negative, which it doesn't. You guys can just see that. Okay, here we go. Got a lot going on here. Can I just, I see that they all have the same base, right? I mean the same log. ln of x minus 2 plus the ln of 2x minus 3 equals 2 ln of x. Agreed? Okay. All right. Well, can I just cross off the ln since they're all the same? No. I can't. We're going to be able to in a second, but I can't right now. It only can be 1 on one side and 1 on the other. Did we learn something 30 minutes ago that would make me be able to just have 1 ln on the left-hand side? What did we learn how to do?
If it's expanded, you have to compress it.
Do you guys see how this is expanded? This is an expanded natural log. Can I smush it together so it's all by itself?
Yes.
Okay, I can rewrite this as the natural log of what? X minus 2 times what? 2x minus 3. How come I can do that? I'm condensing it. Do you see how they both are the same base? They are the same log. They both have natural logs. So I can take the 2, since they're being added, if I rewrite it condensed, addition becomes multiplication. All right, on the right-hand side, can I condense this one a little bit?
Yeah.
What does that 2 become?
A coefficient.
The 2 becomes the exponent. So this is the same thing as the ln of x squared. Now what do you notice? You can cancel out the natural logs because there's 1 natural log on one side and 1 on the other. So when I cancel them out, I now have an algebra problem that you guys have seen for a long time now. Can I solve this to get x equals a number? Yeah, absolutely. Go through the steps. What's x times 2x? 2x squared. X times 3? Negative 3x. Negative 2 times 2x. And then negative 2 times negative 3 equals x squared. I have a quadratic, so that means I got to move everything to one side, combine like terms. Can I take this x squared and move it over here? Yeah. And then I can combine these two? Yeah. All right, so I'm left with x squared minus 7x plus 6 equals 0. Correct?
Isn't it 2?
Okay, yes, I see.
Oh, yeah.
2 minus the 1. Okay. Now what happens?
You factor.
Okay, let's factor it. What times what gives me a positive 6 when I multiply, but a negative 7 when I add?
Negative x minus 6.
X minus what?
6 and x minus 1.
X minus 1 and x minus 6.
Yeah.
Do you guys agree?
Yeah.
Okay, negative 1 times negative 6 is 6. Negative 1 plus negative 6 is 7. Okay, so x equals 1 and x equals 6. Should I just circle this and be like, man, I'm so smart?
No.
Or should I go back and check just to make sure? Because what can you not take the log or natural log of?
No, negative.
A negative number. So x equals 1. If I plug in 1 right here, what is 1 minus 2?
Negative.
A negative. That right away tells you, ooh, this one's not a solution. If I come over here and I plug in 6, what's 6 minus 2?
4.
We're good. What's 2 times 6?
12.
We're good. What's 6? We're good. So 6 works. All right, write this problem down. What does this kinda look like? What does this problem kind of resemble when you look at it?
Quadratic.
Kind of looks like a quadratic, doesn't it? Doesn't it kind of look like 2x squared plus 5x minus 7 equals 0? That's the exact problem that it is. We just have one little extra step. Do you guys agree with me that x times x is x squared? Right?
Yeah.
If I had x times x, that gives me x squared. Agreed? Well, what about if I had e to the x times e to the x? E to the what?
2x.
Why is it to the 2x?
Because it's 2.
Because when you have two x, right? We have two bases out of the same. What do you do to the exponents?
Small square.
You add them, right? I have one here and one here. So all you're doing, guys, this is just a factoring problem that you have seen a million times. But instead of x in the front of each parenthesis, you have e to the x. Now we solve it the same way we've done all of these problems. A times c. What's 2 times negative 7?
Negative 14.
What multiplies to give me negative 14, but adds to give me 5?
7 and negative 2.
All right, so plus 7 minus 2. Is my a term 1?
No.
So what do I do with the 2?
Divide.
Divide both by 2. So you guys have e to the x. You have 2e to the x plus 7, right? Right, this 2 comes out here. And then you have e to the x minus 1. Agreed? Equals 0. Okay, so let's solve this just like we would any other problem. I have 2e to the x plus 7 equals 0. I have e to the x minus 1 equals 0. I want to get my e to the x by itself. So what do? Minus 7. So I have 2 e to the x equals negative 7. Now what? Divide by 2. I get e to the x equals negative 7 over 2. And then how do I solve this? What is the opposite of e? So if I take the ln of this side, then I take the ln of this side. So I have x equals, guys, in your calculator, it's ln of negative 7 over 2. What does your calculator tell you?
Error.
Why?
Because it's a negative.
Because it's a negative. So you can, at this point, you can go right here. Oh, no.
None.
That solution doesn't work. Tell me it doesn't work. By putting a big X through it, you're telling me it doesn't work. So go up here on this side. Solve this one. What do I do to both sides? I'm going to add 1, so I get e to the x equals 1. I want x. I don't want e to the x, so what's the opposite of e?
ln.
So if I take the ln of this side, then I take the ln of this side, so x equals, what's the ln of 1?
0.
Is that an okay answer? Yeah, you can get x equals 0. But you guys will see one of these as a factoring kind of thing. You factor it like you normally do, just at the end you have to solve using natural logs. But your factoring stays the exact same.